are live. Welcome, everybody. I'm super excited for our second talk of the day. We have Kate here, who previously gave a talk for us about a week ago, but was in the Middle East and we couldn't see her. But now we can see her. So I'm super excited to have her back for another talk. Today we're talking about smart contracts and blockchain development, and this is going to be super amazing. A little bit hands-on, but a little bit, theoretical as well. So before we jump into the presentation, I want to get to know Kate a little bit better. And where better to start off than where she was the last time we talked. She was in the Middle East doing some great work. I understand it was a bit of a work vacation, but tell us what was going on there.
Yeah, so last time I gave a talk, all you guys saw was a black screen. So I'm here now. I'm a real person. I was actually in Lebanon. I volunteer with a dog rescue agency. So we flew out there and we brought back 30 dogs. Most of them were displaced and injured in the port explosion. So we were rescuing dogs. I was volunteering there because they have about 900 dogs in their shelter, and then flying them back to Canada to be adopted. So in my other life, I rescue dogs.
Oh, that's amazing.
Yeah.
Is there any crossover with that work? Like, is there any blockchain involved in that work, or is there room for that?
There is kind of a crossover. What I do for organizations is I set them up with like crypto donation buttons on their website so that people can give in like Bitcoin Cash, or Ethereum. That's the only crossover right now. But hopefully there's crossover in the charitable industry with blockchain in terms of like transparency of donations, faster donations getting from point A to point B without fees or without getting held. So I think there is huge opportunity there. But it's a legacy industry, so people are still trying to figure out how to get money from one country to another, add blockchain, and they're like, whoa.
Yeah. I love that use case for blockchain. That's like one of the huge main use cases for me. I believe that we need more privacy in our own personal lives, and we need more transparency in the corporate government, and of course, like a huge part of that is the charity space. Like,
Yeah.
I want to know that my donation is having an impact and where it's going, and who needs to like get that in the end. Super
Yeah.
important.
We just had the big scandal in Canada. I assume a lot of people here are tuning in from Canada with it was supposed to be a few $100s a month for people working during the pandemic with charities. And I think it was the WeWork. No, not WeWork. I forget the name of it, but there was a huge scandal. They had to cancel the program because it was all mismanaged and the money was not going to where it should have gone, which, never heard of that before.
Exactly. Yeah. It wouldn't happen if we had some open, transparent blockchains. We'd know exactly where it was going.
Exactly.
Oh, man. So I know you're a veteran in the space. You've been developing on Ethereum, particularly for the past few years. And I can only imagine, like, it's a new industry. So I imagine like the tooling and the education when you were entering the space was not as good as today. So tell us a little bit about what your experience has been learning to develop on Ethereum, what kind of tools you had then, and what kind of tools you find are available now.
I mean, the wonderful thing about Ethereum is that I'm going to get to it in my presentation, but the IDE, the Integrated Development Environment Remix, has always been really, really fantastic. It's always been really accessible. Like you can, it's just a web page that you open up and can start developing on. The documentation is really well written. Whoever's in charge of that, like, fantastic. But at the beginning, it was very much, not you're on your own, but you had to read through the documentation, play around, and just kind of see what works, see what didn't. And as you were developing things, you were kind of setting precedent in real time because this was a new technology. So anything that you built, it could have, potentially be the first of its kind, which was really cool. And that's still the case. But now you have huge developer communities behind you. So rather than working through something yourself, you've got huge communities that you can reach out to. There's now like big hackathons, like all like the ETH Denver, ETH India, there's huge hackathons that allow for really, really cool community building. Now it's all virtual, which is great for community building as well. But there's just really like that community aspect that's evolved with Ethereum, which is wonderful because it's got a really great community behind it that's really supportive and really innovative. Like any crazy idea you have, there's someone out there who's like, yeah, let's do it. Let's build it.
That's awesome. I'm glad you mentioned community because all the folks I see have trickled into the cast so far. You are now a part of our community. Welcome. If you haven't already signed up for BlockHack, be sure to head over to blockhack.ca, sign up for the hackathon, and join the community. You can meet us over in Discord, and we are here to support you as we help build up the blockchain space by supporting people and giving them education and mentorship in order to build businesses in the space, because that's how we're going to reach that adoption. That's how we're going to affect the change, by building actual sustainable businesses. So we are about to jump into an amazing talk with Kate, but before that, I want to point out a couple things. Of course, we have a lovely chat right over here that you guys can, discuss the interesting topics that we're going to talk about throughout the talk. But also take a look down at the bottom of the screen there. There is an Ask a Question button. If you have any questions during the talk, please drop them in there. If you see a question there that you would love to get answered, give it an upvote, and we'll get to the questions in order. Kate says that I can interrupt her, so if there's any super important question that you'd like to ask during the talk, please drop it in there, and I will jump in and make sure that Kate gets that answered for you. And just beside the Ask a Question button, there is a polls button. And there are a few polls that we would like to get some feedback from you guys on. I see some answers coming in already. The questions are: should private blockchains be called blockchains? We have two possible answers: yeah, totally, or no, they're against the whole ethos and we should call them something else. I see a 50-50 split so far. We're going to check back in on these towards the end, but I like seeing the split already. Next question is: will smart contracts remove the need for real estate agents specifically? That's going to make a little bit more sense as we talk, go into the talk today. But we'll see what the answers are there. And do you think that Hyperledger specifically is the future of enterprise blockchain, or are there some other options there? And we have a couple options listed. So check out those polls while we dive into the talk. But I'd like you all to help me introduce Kate. She has a degree in strategic management and entrepreneurship, as well as a degree in English literature and professional writing. She has a background in cybersecurity and has been developing on the Ethereum blockchain for the past 3 years. Kate founded the Concordia University Blockchain Club and is a community organizer at the BDU, the Blockchain Developers United group. She has also worked extensively in the nonprofit world, focusing on creating sustainable community-based projects and developing and in post-conflict economies. Currently, Kate is developing an offline cryptocurrency payment remittance system, which is super interesting. And I'd like you all to give a nice, warm digital welcome to Kate Stapleton. Thanks for being here, Kate.
Thanks for having me. I'm excited.
And you can take over the stream.
Okay, let me just share my screen. All right. So, all right, are we good? Can everyone see the screen?
Perfect, yep.
Awesome. So, that was a great introduction. Thank you. My name is Kate Stapleton. I'm also the VP of B.E.N, which is the Blockchain Education Network. So we're a global network that provides resources for primarily university blockchain clubs, but we're expanding to reach high school students, anyone who's interested in blockchain development, learning about the space. Thank you for having me on behalf of B.E.N. So my talk today is going to focus around what are smart contracts. I'm sure we've all heard of smart contracts. If you haven't, that's great. I'm going to kind of give you a crash course. So the lesson overview, I'm just going to do a quick overview of Ethereum. Then we're going to get into a smart contract overview, so how they work, and then I'm going to talk about an airline insurance example, so a real-world example of a smart contract that's in use right now. Then we're going to get into enterprise-grade blockchains, so Hyperledger, what it is, and then chain code, which is Hyperledger's version of a smart contract. And then to end, I'm going to get into some real-world implementations of smart contracts. So I'm going to talk about the Walmart example, how they're using smart contracts, and then a real estate example. And then I'm going to end off by showing you guys what a smart contract looks like on Remix. So just a quick overview of Ethereum. So Ethereum uses blockchain technology born from Bitcoin to decentralize other industries than just finance, right? So some of these industries can include voting and household registries. And Bitcoin is written in a Turing incomplete language, meaning it can only understand a small set of orders, like who sent how much money to whom. So building off of that, people wanted to create a more complex system, right? But we needed a different language and a different network of computers to do so. And thus was born Ethereum. It's a DIY platform for decentralized applications, also known as dApps, that are written in Solidity, which is Ethereum's programming language. And the Ethereum platform has thousands of nodes or computers, making it decentralized like Bitcoin, that run programs deployed on the network that execute them exactly how they're written. And Ethereum, it's the infrastructure to run dApps, decentralized applications, and not a currency. The currency used to incentivize the network is called Ether. And Ethereum was created to decentralize the internet, right? Which is kind of a little confusing when you hear it at first. But the majority of the platforms that we use, right, Facebook, Google, etc., are actually centralized. And so Ethereum's goal is to decentralize the web. So essentially, it's a bunch of nodes that are working together to create kind of a supercomputer that executes the code that run on these decentralized applications or dApps. And as I mentioned, Solidity is Ethereum's coding language. It's used to write smart contracts, which are the logic that run these decentralized applications. So developers write the conditions for their programs, the dApps, and the Ethereum network executes them. So Ethereum was launched with the idea that code is law. However, after the DAO, the Decentralized Autonomous Organization incident, where weak code was exploited to essentially drain the DAO of all of its funds, the Ethereum community came together and decided that code is no longer law to that degree, and changed the Ethereum rules to refund all of the money that had gone into the DAO. And the original Ethereum blockchain is called the Ethereum Classic, so for those who didn't want the money to be returned. And the Ethereum we know today has altered protocols from the original. So when people talk about the price of Ethereum, they're actually talking about the price of Ether. And we're going to get into a smart contract example at the very end. But basically, it incentivizes people to run the Ethereum protocol on their computer. And authors have to pay an Ether to deploy a smart contract to the Ethereum platform. And this is so that developers write efficient code and don't waste the Ethereum network's computing power, since it will cost them money. So kind of lightning fast overview of what Ethereum is. So let's get into smart contracts. So what are smart contracts? How do they work? Basically, they're computer programs stored inside a blockchain. They're immutable and distributed, digitally created and executed contracts. They can exchange money, property, or really anything of value. And you can add information and cryptocurrency into a smart contract and receive your personalized like escrow, rental agreement, etc., that is added to your account. And smart contracts, they can define rules and penalties just the same as any traditional contract can, but they can also automatically enforce them. So a rental agreement, for example, right? It can be automated through a smart contract over the blockchain. So you pay in crypto and you receive a receipt held on the virtual contract. And the other party sends a digital entry key, which you will receive by a predetermined date that both parties agree on. So if the key doesn't arrive on the date stipulated by the smart contract, you're automatically issued a refund. And the key can be sent before the release date, where it would be held until the key and the payment are released to each party on the correct date. So if a landlord, for example, is using a smart contract, they don't need to collect the money. The contract knows if the money has been spent or sent. And so why are they called smart contracts? Well, they're called smart contracts since they handle every aspect of the contract. So enforcement, management, performance, and payment. And so essentially they work off of the if-then premise. So if there's any coders that are listening, you know what I mean. What that is that, so the if-then premise automates their execution and it relies on conditions and actions. So if this occurs, then this occurs as well. So smart contracts, another part of what makes them smart is that they're executed in minutes rather than days or weeks. And since the conditions are predefined, remittance for them is automatic. They're also a completely transparent system. So archiving is simple since all the contracts can be traced. And the contracts are signed by a private key, so they can't be forged. So here's a traditional contract, right? You have two parties, A and B. They sign a contract, it goes to a third party, and then there's the execution. Whereas with a smart contract, you don't need that third party. So you have two parties, A and B, that agree in a contract that is automated. So it's a smart contract, and execution is also automatic. And so similar to a vending machine, there are self-executing contracts containing all the terms and conditions of this agreement between the two parties, right? So the terms and conditions are written in the code of the smart contract, and they're executed on, in this case, Ethereum's decentralized platform. So for example, a smart contract might ensure that a new car delivery is made within a specified time frame, or that funds are released according to prearranged terms that the two parties agree on. Or they can be used to improve the flow of goods or capital, respectively. So there we go. So what are some of the advantages of smart contracts? Well, there's no middlemen, right? You're cutting out the need for a trusted third party, so people can interact directly with each other. And because of this, there's huge savings, right? You don't need to pay that trusted third party. Code is law, right? So you, as I discussed with the DAO, it means it's a little bit of a different meaning than originally, but essentially what is written in the smart contract is going to execute. So it's immutable. You can't go in and mess around or change the terms after they've been executed. There's backups. There's default backups, right? It's all part of the public ledger. You avoid the manual error that comes with people writing contracts, with people executing contracts. So you cut out the possibility of human error. Trustless execution, right? Because you're cutting out the middleman, you don't need that trusted third party. And there's also autonomous execution. So an example of an Ethereum smart contract that's being used in the real world is AXA, which is an insurance company. They have flight delay insurance that's linked to a database that records the status of flights and provides automatic compensation when there's a delay of 2 or more hours. So like I said before, smart contracts are created based on terms and conditions. So that's the condition. This gets back to the if-then. So if a flight is delayed for more than 2 hours, then the account will be credited with the appropriate amount. So the condition is compensation equals flight delay of more than 2 hours. And based on the contract's code, the money is held on the blockchain until a condition is satisfied, at which point the smart contract is submitted to the nodes, right? The machines, the computers, on the EVM, the Ethereum virtual machine, for evaluation. So the EVM, it's, like I said, it's the electronic, not Ethereum, electronic virtual machine. And it's the compiler that executes smart contract code. And all the nodes on the network that execute the code have to come to the same result. So with this example, If the flight is delayed for more than 2 hours, a smart contract self-executes and compensation is delivered to the recipient. There's no paperwork, there's no middleman, there's no submission process, and there's no wait time, right? So think about traditional airlines. If you want to even get through to a live agent, how long it takes, and then imagine the reimbursement process and how long that takes. This handles it autonomously and within seconds. So once a smart contract has been deployed, it can't be edited or corrected by anyone, including the author, since it's immutable. And you can create really complex contracts on the Ethereum network, but you need to ensure the code is sound, obviously, since once, like I said, the smart contract is deployed, there's no going back. So make sure you write good code. So I'm going to now get into some business examples. And with that comes the enterprise-grade blockchains. So there we go. So Hyperledger, I'm sure a few of you or the majority of you have heard of Hyperledger. It's one of the best and well-known enterprise-grade blockchains. It's the umbrella term for many different frameworks, the most popular being Hyperledger Fabric, which I'm sure some people have heard of. So an enterprise blockchain, for anyone who doesn't know, it's a private blockchain. And so basically, a private blockchain means the participants, they must first gain permission. So these participants could be a regulated authority, or like with Hyperledger, right, a consortium, for example. So not anyone can join. And as the name suggests, these blockchains, they've been specifically designed for enterprise-grade use and needs. And they're a little bit polarizing, right? Because some argue that they're not true blockchains since they're not truly decentralized, right? Since not everyone can participate, only regulated actors and nodes. So there's interesting discussion that accompanies enterprise-grade private blockchains. But basically, with these, there's three key features, and the first one is high performance. So they need an architectural approach that allows for really fast consensus protocols in optimized environments, as well as really efficient onboarding processes. The second one is high resilience. So basically, they need to be able to quickly come back from any downtime and potential failure and avoid any issue leading to any sort of outages. So you have huge organizations and multinationals using this technology, and so they really have to have strong systems to make sure that there's very little or no downtime. The last one, privacy. This is a big one, right? This factor is what really necessitates the need for a private blockchain, since all participants on the network, they're known and vetted before they're granted permission to participate. And privacy, it's a huge concern for large organizations because their internal processes and data, it's very sensitive and it's not publicly available information. That's why it needs to be private and permissioned. So, get into that in a sec. So basically, what is enterprise-grade blockchains? What do they have to do with smart contracts? Well, as I mentioned, Fabric by Hyperledger, it's the most popular framework, and it supports smart contract development in general purpose programming languages. So I mentioned Ethereum's Solidity programming language before, but with Hyperledger, it uses general purpose programming languages like JavaScript, Java, Go, and Node.js. And Hyperledger's Fabric, it's also operating under a governance model to build trust between the participants on the shared network. And on this network with Hyperledger, smart contracts are actually called chain code. So that's kind of the main difference in terms of in terms of what they're called. There's some very technical differences, but we're not really going to get into that today. So the idea is that with Hyperledger, right, before businesses can transact with each other, they need to define a common set of contracts that cover the terms, data, rules, concept definitions, and processes. And taken together, right, these contracts, they lay out the business model that governs all of the interactions between these transacting parties. And the smart contract, it defines the rules between different organizations in executable code. So applications, right, they call a smart contract to generate transactions that are recorded on the ledger. And Fabric turns these contracts into executable programs, right? Smart contracts or chain code which can implement the governance rules for any type of business object. So they can be automatically enforced when the smart contract is executed. So most importantly, right, the execution of a smart contract, it's much more efficient than a manual process. So for big businesses, this is a huge advantage because it cuts out the time, the paperwork, the possibility for human error, and all of those accompanying factors that traditionally legacy systems and industries face. So, oops, there we go. So here, we can see how two organizations, right, organization 1 and organization 2, have defined a car smart contract to query, right, transfer, and update cars. So applications from these organizations would call this smart contract to perform an agreed step in a business process. For example, in this case, it's to transfer ownership of a specific car from organization 1 on the left to organization 2 on the right. So we're going to get into, an Ethereum smart contract on the Remix IDE after, but this is kind of the basic, basically what smart contracts look like in a very, very, very basic sense. So this said, what organizations are actually being run with the help of blockchain technology, right? Like what organizations are actually using this? Well, a really well-known case study for the Hyperledger Fabric, which I mentioned, is Walmart's integration into their food supply chain management. So the challenge that they faced, and this is a really interesting use case I find, was that when the outbreak of a foodborne disease happens, it can take days or weeks to find the source, right? Think of the issues that we had last year with salmonella in lettuce. So better traceability would help save lives by not only allowing companies to act faster and protect the livelihoods of their customers, but also the livelihoods of the farmers by only throwing away the produce that came from the affected farms rather than everything. So Walmart took the approach that through the use of blockchain technology, it might be a good fit for the decentralized food supply ecosystem. So they looked at a bunch. They looked at Ethereum. They decided on Hyperledger. And to test this, the company created a food traceability system based on Hyperledger Fabric, as I mentioned. And Walmart, they ran 2 proof of concept projects to test the system. So one project was about tracing mangoes sold in the US stores, and the other one was used to trace pork sold in the Chinese stores. And the blockchain-based food traceability system, it's a bit of a mouthful, built for these 2 products, it worked. So for the pork in China, it allowed uploading certificates of authenticity to the blockchain, which brought a lot more trust to a system that used to face serious trust issues. And for the mangoes in the US, the time needed to trace their provenance went from 7 days to 2.2 seconds, which is pretty amazing. So Walmart can now trace the origin of over 25 products from 5 different suppliers using the system powered by Fabric. And they actually just recently announced that they're going to start requiring all of their suppliers of fresh leafy greens like salad and spinach to trace their products using the system, which is really cool. So they're expanding as well. So the other products that they're now planning to track with Hyperledger is produce, meat and poultry, dairy, and multi-ingredients products. So it's a really cool application that a lot of people benefit from without even knowing. So for the mango proof of concept, how it works is a packet of sliced mangoes was bought at a Walmart store, and the team was asked to identify which farm they'd come from as fast as possible. And the team started calling and emailing, right, which is usually how it's done, all of the distributors and suppliers, and eventually had an answer about 7 days later, which for the industry is pretty good. So the team then worked to automate this, and they worked with GS1, which is the standards authority in barcodes and labeling. I didn't know that either. to define the data attributes for the mangoes, which were then uploaded to the blockchain. So Hyperledger then wrote the chain code to be executed to support this process. Suppliers then used the new labels and uploaded their data through a web-based interface. And the result, as I mentioned, was that mangoes in the US were able to be traced to the source, tracked to the source in 2.2 seconds rather than in 7 days. So a huge, huge improvement. And Hyperledger Fabric, it is open source, and it's a vendor-neutral blockchain, and that can be used by anyone. So Walmart's competitors can use the same system as well. So here we go. Another example is in real estate. So smart contracts in real estate. It's actually a really interesting. It's a really interesting development that there's still a lot of opportunity in. So if anyone, has bought or sold a house before, you know that it's a process that involves many, many stakeholders. And so this diagram here, it depicts a typical real estate scenario. So in it, the agent, right, is in the center, the realtor, and he or she is coordinating all events. In this model, the agent acts as the trusted transaction facilitator. All involved parties need to rely on the agent throughout all stages of the process. And there's room for disruption with this, because the core idea of blockchain is to transfer assets without needing intermediaries, and changing the role of mediators. As I said, this presents a really interesting use case in real estate business. So the high stakes, right, and all the stakeholders involved in a real estate transaction, they lead to a really lengthy and expensive bureaucratic process. So the intermediaries currently work as gatekeepers for the sake of the system, right? They're there for the system, really, rather than for the buyers and sellers. So introducing automation, that removes friction, which I think makes a lot of sense. But I do want to be clear, middlemen do still have a critical role to fill. You still need someone to set up the contracts, to verify, and to enforce them currently. But using a technical solution to transfer trust like the blockchain, this provides immense opportunity. So in this new system, the real estate agent, they no longer sit in the middle, but the real estate agent, they no longer sit in the middle, and they no longer carry the burden of orchestrating the whole transaction. So instead, right, the agent can now have a more passive and overseeing role. So this hybrid approach can really help restore trust in the process, and you can reduce the individual broker's influence over the transaction so that the agent becomes an unbiased part of the process. So here is kind of how it works right now. Everything goes through the realtor. There's negotiations, that go through the realtor, from everything from a co-op to the house inspector, the buyer and seller bank, and the seller. And now in the middle, you have the smart contract. So the realtor is still involved. They're still a key player, but they're no longer in the center of everything. They're replaced with the smart contract. So smart contracts, they help you set up agreements and the rules that govern transactions. Not only can you decide what amount goes from one stakeholder to another, you can also set up conditions for when and how to transfer the money. And this can apply to real estate in the form of the down payment. So the down payment is one condition in a chain of events that the buyer needs to fulfill. And with smart contracts, there's a neutral central coordinator, right? This presents the opportunity for that. And this is a system that people cannot manipulate. And in it, all interactions and conditions are transparently shared with everyone. So for example, right, all parties would know the instant that the buyer completes the down payment. The smart contract also regulates what happens if things fail, or if things fall through, right? Should something down the line go wrong, like an inspection, the system will return the money. And in the future, as this system of smart contracts evolves, and as we kind of push the limits of what's possible, and as adoption hopefully catches up, we might not even need the real estate agent. So sorry if there's any real estate agents listening right now. So at least not for the transaction. And here's a possible future scenario where the sellers and the buyers can facilitate the home transfer completely on their own. So the real estate agent is taken out of the equation, and it all goes through different smart contracts. And in this scenario, the traditional contract can be replaced by a computer program. It comes pre-programmed with all the rules that the stakeholders need to fulfill, and these encoded obligations are what will move or can move the deal forward. So when all conditions are met, the transaction completes and is completely automated. And smart contracts, they can cut out lawyers, paper contracts or amendments, which is important as well, since they can't be retroactively changed. And above all, right, each transfer needs no upfront work. And what's cool about smart contracts is they're infinitely reusable, and they also produce no waste in terms of paper. They just need electricity. So transferring a home, right, in theory, can go from weeks to minutes, which is pretty cool. And in the best case, even seconds, right? If everybody has already agreed and fulfilled their parts and are ready to sign, right? In theory, it can be executed in seconds. And due to the trust protocol, parties don't need to meet face-to-face to sign documents. So if you want to sign, if you want to sell or buy property and you're on opposite ends of the world, you don't need to be face-to-face anymore to sign these documents, which is pretty cool. And so if you write this diagram, right, in the future, there's no, I'm sure there's arguments for both sides, but in theory, you can completely cut out the buyer and seller bank. So initially, right, banks can switch over to blockchain transactions to support smart contracts. But over time, when the technology, hopefully is more widely adopted, buyers and sellers can perform transactions without the banks as middlemen. And again, I'm not saying that this is going to happen tomorrow. I'm not even saying that it's going to happen this way. I'm saying there's the possibility for this to happen potentially in the future based on smart contracts.
So we have a question regarding real estate. How is the authentication implemented for each actor, like the buyer, the seller, the house inspector, lawyers, bankers, all these people involved? Like, how is it? I think what they're asking is like, how do I know this person actually owns the house? How do I know I'm gonna take possession of the house? Like all these different authentication steps.
So this is where blockchain and smart contracts has to kind of meet the real world. So there would have to be a pretty extensive KYC process. I know that's kind of one of the advantages is that you can exchange and interact directly with people on the network, through their addresses. But for this process, if this was going to scale and actually be a viable option, there would have to be very regulated and thorough KYC processes involved. Because you're dealing with large sums of money, right? So in property. So there would be KYC processes that would have to be involved.
Yeah, and we had a talk earlier this week with a person that works in government contracting and drawing the correlations between smart contracts and their legal enforceability, because that's also like a piece that needs to come into play here.
Yeah, I mean, it's great that there's all of this potential to decentralize these industries, right, and to replace traditional contracts with smart contracts. But as I said, to really scale and to be adopted, it does need to tie into regulation to make sure that, it's legally recognized that you've transferred ownership from one party to another. So that is a key process as well. So in this case, it would be very thorough KYC as well as compliance with laws and regulations that each government in their country have stipulated.
Awesome, thank you.
Yeah, so kind of tying into that, right? Loans and mortgages, they can be programmed into smart contracts with many distributed loan providers that don't need to be coordinated anymore. And the blockchain doesn't only work as a trust protocol, but also it has a networking effect, right? So the system of smart contracts can easily be expanded to include other services and kinds of stakeholders, which is cool. So here is a small extract written in Solidity where people and the state of the contract are enforced. And with specific roles and with a state machine, the system makes sure that the right person signs at the right time. So that also kind of feeds back into that question. So here's the function: seller sign contract, require, the seller. So only seller can sign contract, and require contract state, right? Wrong contract state. And then the contract state equals a contract state, which is waiting on the buyer signature. So if you want to check this out more, there's a really cool GitHub repo called Norbandev/Real Estate 2.0 that really gets into like kind of the back end of what real estate smart contracts look like. This is just an excerpt to show you kind of one component of it. But yeah, I would encourage anyone who's interested to check out this GitHub repo. I can also drop it in the chat after. It's really cool. He gets really in depth about the future possibilities. So speaking of smart contracts, right? Let's look at one. So just gonna exit here. All right, so Remix. What is the Remix IDE? Well, the IDE stands for Integrated Development Environment, where we build our smart contracts. And you can access the Remix IDE from your web browser, and you don't need any sort of special installation, right? So it's literally just remix.ethereum.org. And you're presented, as you can see here, with a complete IDE with a code editor and various panels to compile, to run, to debug your smart contracts. So if you see here, you have a default ballot contract that you can play around with. And it's everything is .sol, right? .solidity. So I just created a basic hello world.sol smart contract. And to add one, you just click this little button here, you name it, and then it creates a new file. So this code editor, right? It's all in Solidity. It provides the interface where you can write your code, and it includes syntax highlighting, auto-compiling, etc., which is great. The terminal down here is at the bottom. And we'll get into it in a sec, but there's compile tabs that will compile a smart contract, and you can publish it on Swarm directly. So if we look here, there's the three possibilities, right? There's three options in the Run tab. This is called the Run tab. So there's JavaScript VM, which is a sandbox blockchain implemented with JavaScript. It's in the browser to emulate a real blockchain. But if you choose this and exit, all of your changes are lost, right? So this is just the one I'm going to be using today, but you wouldn't necessarily want to use this one. Injected Web3, that injects Web3 like Mist and MetaMask and connects to your private blockchain. And then here, the Web3 provider, it's a remote node with Geth or any Ethereum client, and it can be used to connect to the real network or to your private blockchain directly without MetaMask in the middle. And so just a quick side note of like what is Web 3.0. Web 3.0 allows online applications and websites to receive information on the web and give new information or data to the users, right? So like the algorithms that track your behavior and recommend things based off of it, the website is learning and becoming more intelligent. So that's kind of a side note. So under environment, there's a bunch of accounts. These accounts help simulate different people interacting with your smart contracts. Then there's the gas limit. This avoids endless loops and processes running on the gas chain. Sorry, the blockchain, the gas chain. And if you run code on the blockchain, you perform operations. Each one costs gas. And with the gas limit, setting the cap on the amount of these computational operations that you can do. So this caps it. So this is how much gas you want to spend. So again, you can set it. And with value, right here, you can, this essentially sets the value that you can send along with your smart contract. So I just leave it at 0 away for this. So let's actually look at the code here. So here is our very, very, very basic smart contract. So every Solidity program, it starts with a pragma line. So the line at the top right here. And
sorry to interrupt,
yeah.
Kate. Are you able to make the text a little bit bigger? It might be tough for folks.
Is that better?
Yeah, that's a lot better, yes.
All right. Oh, yeah. Sorry, I didn't think about that. There we go. All right.
Thank you.
So, yeah. So, as I said, every Solidity program, it starts with the pragma line, so the first line. And this tells the compiler which compiler version the Solidity file was written for. And every smart contract starts with the keyword contract. And it uses cap words, right, or camel case for style for the contracts and libraries, meaning in this case, hello world. So hello and world is capitalized. And classes are a really key part of Solidity, and using the cap word protocol helps to identify classification identification, and function, so that not only can you retroactively follow the logic, but other programmers who are going to be looking at your smart contract can as well. And all of these stylistic choices in the writing of the code, right? These are part of Solidity's syntax. And if anyone's interested in learning more, there is really, really great documentation, or learn the docs on the Ethereum's website regarding Solidity. So you have your contract, hello world, and then we're going to open the curly brackets to write the contract body, which is the contract code. And so this here, this means comments. So this is not going to be part of the smart contract. So this is just a comment here that right here, this will be permanently stored in the blockchain. So contract, hello world. And so similar to how you would create a class in Java, if anyone is a Java developer, or any, really any other class, really. So your contract code would mean variables, usually class variables called storage variables. You can also have functions and modifiers. So here we're going to, this is a very simple string. So in this string, it's a reference type. So it's called hello world equals hello world. So you initialize it in double quotes, and then you close it with a semicolon, which is very important because a lot of debugging, it's just missing semicolons. And so down here, right, for another function, we can add another function under the string. And so they start with the keyword function, and then you write the function name, which is in the mixed case style, right? So write hello world. And in the round brackets, you have the arguments that this function will take. And in this case, it takes a string. So the string is called underscore hello world, and it's a reference type. And in Solidity, you have to specify where the reference types are stored. There's 3 locations. So call data, memory, which is RAM on the computer, and storage, which is your hard drive. And so for this example, we're storing it in memory. And after the brackets, then there's the function visibility specifier, which tells Solidity if the function can be called from outside or inside other smart contracts. And there's 4 visibility specifiers with Solidity. There's public, which is the one that, that we're using, as you can see right here. It's labeled as public. There's also private, which means you can call the function only from within the smart contract. There's internal, which means that you can call this function only from within the smart contract or ones that extend to it through inheritance, through contract inheritance, as Solidity is an object-oriented programming language. And finally, there's the external that specifies that you can call this function only from outside of the smart contract. So now you right down here, you can take the hello world function and write it into the variable. So hello world is hello world right here. So basically this underscore is used right here in the arguments to provide a distinction for later when you would access it with JavaScript API. And so this is, again, this is like a very, very basic smart contract. You're not tracking, the Mango supply chain using this. But here, you can, we can compile it. So it's compiling. And now we have our contract, right? So here's the contract, hello world.solidity. And down here is the terminal. So there's all the information on the smart contract. So you can publish it on Swarm, publish on IPFS. There's also the compilation details that are going to pop up if you want to look at them. I usually like to put on auto compile. It's just a side note. But so then here, you can deploy the contract. And so here we go. It's been successfully deployed. And if you have multiple contracts, you can scroll down. But basically, like I said, this is a very, very basic smart contract. And this is kind of the back end of what it looks like. So while there are incredibly, complicated and interconnected smart contracts that power a lot of the, or all the processes that I mentioned, this is how they all start. So it can seem very overwhelming, but, the IDE is publicly available. You don't need to download any special extensions for, to get started. And it's all here. So it's pretty straightforward. So yeah, that kind of covers smart contracts from what is Ethereum all the way through to real world examples and what they look like on the back end, written in Solidity. So yeah, thank you.
Amazing. Thank you so much, Kate. I'm going to switch us back to side by side. That was amazing. Thank you very much for that chat. We have a couple questions from the audience. There was a massive question here. I was trying to pick out. It's like several questions all baked into one. But they touched on, you know, working with wildlife and biodiversity, tokenizing data to do with wildlife. I think all of it is kind of like tying into your work with dogs and blockchain together. So, do you have advice for people that want to use blockchain to affect, you know, populations of wildlife and how that can be done?
So I don't have too much experience in that side of it, but there is a really interesting use case that WWF is using. Is currently I believe they have a proof of concept. They want to provide I believe it's secure data distribution for conservation projects. So like monitoring wildlife, and then like tracking the kind of the supply chain of like different species, and doing that through the blockchain so that the information is immutable and it's also part of a public ledger. So that's not the enterprise grade side, that would be the more public side. So that could be done using, you know, Ethereum. But there's really, really interesting use cases that blockchain presents for all sorts of industries. So I kind of covered the business side, but like I said, for donations, right? Payment remittance systems, guaranteeing that funds get from point A to point B with very little fees, with no intermediaries like governments or banks that are corrupt. And then tokenizing, right? Like being able to actually track information through the blockchain. These are all potential use cases that we're just beginning to explore. So yeah, WWF has a really cool proof of concept that they're currently working on. So I would check that out. But yeah, there's a lot of interest in wildlife conservation in blockchain, which is really cool.
Awesome. Thank you so much. Yeah, okay, so there's another question here. This question's asking about self-sovereign identity. So do you see possibility of integrating self-sovereign identity with smart contract for BC? Is that blockchain maybe?
Yeah, I would. Yeah, I think there's really interesting potentials for that, right? To manage your own identity, right? If there's a really cool initiative that I believe it's the government, Estonia. It's called e-Estonia. They've uploaded essentially everything they can to the blockchain. So all of your like medical information, for example, it belongs to you. So you are the custodian and the proprietor of all your information. So all of your x-rays, your prescriptions, everything you can not only access from anywhere, but it belongs to you, right? And this ties into identity because that also builds, you know, identification. And we're seeing as such, you know, now with all the refugee crises and the migrant crises, people are fleeing their countries and they have no form of identity, right? Paper, like passports and, you know, identification. What if you lose that, you lose it. And then these databases, because they're centralized, if they're bombed, right? If the country is corrupt, if there's a coup, you lose your identification. You lose your ability to contribute meaningfully to society. And so with self-sovereign identity, I think there's a huge, huge use case that's coming about kind of by necessity, by having all of these people who have no way to manage their identity, who have no way to prove who they are. And then when they come to the new, you know, to new countries, there's no way to really start their life because they have no documentation. And so we're seeing legacy systems that can't keep up with the crises that we're facing. So I think there's a really huge opportunity to integrate smart contracts and blockchain for self-sovereign identity management so that you don't need to be beholden to your government, which could crumble. And, you know, and I've done some work in Africa and there's no national identification system. So for banking, they ask you for ID. And there's no, driver's license or national identification system, like I mentioned. So people just don't bank because there's no way to identify themselves. A lot of these people, they're not born in hospitals because there's no hospitals, so there's no birth certificate. So, there's huge issues that legacy industries have proven to not be able to tackle, where I think blockchain can begin to tackle those issues.
Yeah, I think that's a huge problem, a huge nut to crack in this space. So much opens up for us once we can have a self-sovereign digital identity. Like you mentioned some of them, but as we're seeing with the election going on a little down south in America, the voting by mail, it's so controversial, and these sorts of things. And I think Estonia is already doing it. They're kind of like the pilot test for it's time to vote. Boop. I just voted. How simple is that, and how secure also is that? But it's always the adoption issue, and it's very interesting to see how this is going to roll out.
And that's another thing is adoption. And this is why enterprise grade blockchains can be a little bit controversial, because you have, the blockchain purists who are saying, well, a blockchain is decentralized. So when you have a private blockchain, it's not decentralized, it's permissioned, and thus this is not an actual blockchain. But then you get kind of what I call, and this may get me in trouble, but the intellectual honesty that we have to say there's this technology, blockchain technology, that we want to scale. And in order for it to scale and replace legacy systems, we can't just come in like it's the wild, wild west, guns blazing. You have to comply with regulation, or else there's no incentive to switch from legacy to disruptive technology, right? Governments are not going to want to switch to quadratic voting or any sort of blockchain-based voting if there's no compliance, if there's no governance, if there's no regulation. And businesses, they're not going to want to switch from the way that their supply chains were managed before to blockchain if all of their internal processes and information and data has to be public. So there are trade-offs in terms of regulation that have to occur for mass, adoption to be supported. And enterprise blockchains and permission private blockchains are part of that, as well as regulation if we want people to be voting by blockchain,
Yeah.
So.
Yeah, it's very much like the chicken or the egg problem. It's like we don't want to trust a system that hasn't been tested, but there's nobody willing to implement it to be tested. So it's this back and forth that we'll continue the dance until finally we reach that inflection point where everybody's using blockchain and they don't even know that they're using blockchain, and that's it.
And that's what's cool about Walmart is that, the majority, like I said, all the produce that's being tracked, people don't know that that Walmart's using blockchain, and they are. So that's kind of another facet of mass adoption, is it's just quietly occurring in the background. Mm-hmm. Consumers don't need to know that this mango is tracked over the blockchain. Mm-hmm. They just need to know that it's safe. And if there's an outbreak, 2.2 seconds, they know where it comes from.
Yeah. Slowly, then all at once. Is how it normally goes, and I'm excited to be on this journey with you. All the folks here in the chat, you guys are a part of the early adopters, the early minority, and it's great to be on this journey with you and building up this space. Let's take a look in on the polls and see what came out of it. And also, if you're thinking of any questions, please drop them in the chat. We have a little while more to answer some questions, but let's take a look at these polls. Should private blockchains be called blockchains? We do have some folks saying that they want to call them something else. 23% are saying let's find some other word. I'm interested what you guys think we should call it.
I want to see in the chat what people want to call them.
Drop it in the chat. But 76% or 77% are saying totally cool. We should call them blockchains. I see a DLT, distributed ledger technology. That's kind of a catch-all term. I've heard that used a lot. It refers to everything, especially even Google spreadsheets are a distributed ledger technology. So yes, you're right. But can we be a little bit more specific? What can we call it? They are a private enterprise, 100%. 100% they are. Let's take a look at another question while you guys put in suggestions for what we should call private blockchains. Will smart contracts remove the need for real estate agents specifically? And we have a bit of a split decision here. We might have some real estate agents in the crowd, because 14% are saying real estate agents are perfect the way they are. Perfect. And
my brother's a real estate agent. He would agree with you guys.
and maybe he doesn't want to learn to code, because I personally think like, yes, we need to disintermediate the things that we can, but there is value to be provided by humans with special skills. And so I think that everybody kind of needs to upgrade their skills and keep improving. So I'm in the middle pack here with the 28% that say nope, they just need to learn to code. I think everybody should learn a little bit of coding. I think it behooves us all. Real estate agents, they can be better use if they know how to use smart contracts, and maybe that, like, creates less friction for them. They get a little bit more of a commission as a result, is my thinking.
Mm-hmm.
And a majority of folks, 57%, are saying disintermediation all the way. Let's go fully autonomous. We don't need humans anymore. We should be sitting on beaches and creating art, which would be fantastic. So let's see the last question here. Do you think that Hyperledger is the future for enterprise blockchain? And we have an overwhelming majority saying nope. Each company should research and develop their own private native blockchains. I like that idea. That's very, very interesting. I'm curious why the majority thinks that. Drop it in the chat, like why you are motivated to say that. But there are 21% saying that Hyperledger will be like the ubiquitous kind of future for enterprise blockchain. I'm thankful.
Did anyone pick the last one?
No, I'm thankful that nobody picked the last one, because I think that's why we're all here. We're building businesses in the blockchain as a part of BlockHack, and that is how we're going to provide real world value, by creating businesses that deliver that value. But yeah, please drop in the chat, guys, what you think we should call private blockchains if they're not called blockchains, and also why you think that Hyperledger Fabric is the future of the space.
Yeah, or like some really cool, like, I know smart contracts, like there's huge use cases for them and there's huge potential. So if anyone has some really cool projects that they've heard of, if anyone has something that they're working on, or something that they're interested in using smart contracts to disrupt or decentralize, always looking for cool new stuff to learn about.
Yeah. So there's another question from the audience.
Mm-hmm.
Okay, so with the real estate example, would buyers be required to use cryptocurrency only, or is there a way to implement it using fiat currency? This is a very tricky one. I want to see how you navigate it.
Yeah, so I mean, right now with the systems that we have in place, it would be cryptocurrency, or you would use a kind of like a one-to-one. So like Celo Gold, like a stable coin. So you could, you'd use a stable coin. They're mostly all tied right now to the US dollar. So it would be a cryptocurrency, but it would be a stable coin. So it's, it's either collateralized one-to-one or over collateralized if you're using, cryptocurrency to collateralize it. But that would be right now how that would integrate. Obviously, expecting people to use blockchain, in the real estate sector, and then being like, oh, you also have to use cryptocurrency. You've never used it, too bad. That's a big ask for people. So the onboarding process, right, would have to be, the barriers to entry for the average person would have to come down, and you would have to have a stable coin option. There's really no other way, because then you have real estate agents who don't know cryptocurrency either. You have buyers and sellers who don't know cryptocurrency. And so you're kind of trying to push this at them without really incentivizing them. And that's a big thing, is that blockchain solutions work best when the blockchain is in the background. when it's running seamlessly, when the front end user doesn't necessarily have to interact with it, when it's just there to optimize the processes going on in the background rather than impeding the processes that they're actually having to interact with on the front end. That's when it works the best. So having the stablecoin integration that would be seamless would be a really, really important hurdle to overcome before there's really any sort of mass adoption for that.
That's awesome. And yeah, I think you definitely hit on the point. It's the onboarding phase, like asking somebody to get involved with crypto just to buy a house, it might be a little daunting. And we actually had a talk just before yours this morning with B.E. Works, and that it was specifically around that, like how to build better onboarding processes for our technologies. And I think a part of that can be, abstracting away some of the more technical parts of these things. And I know there's also companies out there that are providing solutions for businesses that allow customers to purchase using fiat, but the company to receive it in crypto, or the reverse, purchase things in crypto that instantly get converted so that the business gets the fiat. And
I think BitGive is doing that. Yeah.
So these types of, I guess you could call them intermediaries, but like they are providing a service, and it's a part of that onboarding process. Because once people can see like, this is going on in the background, but I don't have to take on additional risk or sticky friction points, that gets it into the ecosystem, and it gets it into the air where maybe I want to get involved. Maybe I want to research it a little bit more.
Yeah, and I think that's a really good point, especially like in this, in terms of this talk, right? It's for a hackathon, and I think a lot of the mistakes that people make when they're designing blockchain products is they don't have the correct consumer or customer in mind, right? You see a lot of like, it's Uber, but on the blockchain. Well, Uber works. So why are you trying to disrupt, or change something that works? And if the reason is, because it's blockchain based, that's not a good enough reason, right? Like your consumer is not a blockchain. If you want to scale, really, your consumer is not a blockchain enthusiast. Your consumer is a regular person who doesn't know what blockchain is, who's going to be intimidated by it. So these processes should be going on in the background. And like I said, should be providing all the benefits without having the consumer really even aware of it, right? Because that can't be your main selling point is, it's blockchain based. Cool, but the one that you're trying to replace works. So, it has to provide a service that's better than the current one, and also that's just as easy. Because your consumer, your customer is not necessarily, for the most part, going to be a blockchain enthusiast. They're not even going to know what it is. So it's designing products with the correct consumer in mind, and understanding your consumer, and understanding that the second you say blockchain and they have to start doing things that they don't normally do, you've lost them.
Yeah. Okay, so there's a couple more questions from the audience here. You mentioned, I'm not sure if it's Cello or Cello, CELO. Have you evaluated them? And this person is curious about what you think of their onboarding process.
So there's, I think I mentioned Cello Gold, because there's also a Hyperledger product called Cello, but Cello Gold is really cool. I really like Cello. I would recommend people getting involved, looking into their documentation. They just came out with some really great new educational resources, like videos and docs. They're a mobile first platform, which I think is really important, because in North America, it's a second thought. We don't even have a second thought about using our iPhones and being connected to the internet and having all of our, smart devices. Whereas in other parts of the world, the majority of the world doesn't have the luxuries that we have. And so a mobile first platform is a really cool approach, because like I said, designing for your customer and the correct customer, I think they've really been able to hit the nail on the head with that one, to understand their customer and to create products for them, to create a really, really easy onboarding process in terms of like the really accessible documentation that they created. They have a great community. They have a grant right now that they're extending to anyone who wants to create resources. So they're building up their community, and the product works. Like Cello Gold, I really like it. I really like the company. So big thumbs up for them. There's also the Cello Hyperledger product, which is an aside. I don't really know about that one, so don't quote me on that.
Cool, awesome answer. And that kind of leads us into the next question, which is talking about like stable currencies, like stable coins. They're typically, like you mentioned, tied to the US dollar. Now, do
Yeah.
you see a migration in the near future of backing these stable coins to potentially other cryptocurrencies, maybe a basket of cryptocurrencies? Or like how will we value things in the future, and how do you see that playing out?
I think the way that it's going to play out is going to be wholly determined by the use case, so the need for it, right? So if people are needing it to act as a stable coin, if they're looking to transact in cryptocurrency to get around censorship, to get around corrupt banking and governments, to get around high fees and like long wait times, then it makes sense to use the US dollar because that's kind of like the universal currency, right? And it's currently, we'll see, kind of the world currency. That's what is accepted almost everywhere. That's the standard where people value different currencies too. So if that's the use case, then I think that's going to continue to be kind of the driving factor in the leading currency that we see stable coins tied to. And then if other use cases emerge, then if DeFi picks up in a huge way, and as we're kind of seeing it is, that's when you get some really cool different approaches emerging. But again, I think due to the demand, the US dollar backed stablecoin is going to continue to kind of lead the pack, because in my mind, there would be the most demand for it, and there would be the most use cases that it satisfies. The other ones trailing, there's interesting use cases and there's interesting opportunities there, but I don't think the demand is there yet, because we don't even really have a strong demand for the US dollar-based cryptocurrency stablecoin, and that's still the one leading the pack. So it's kind of like a trickle down. But yeah, it's going to have to do with what's driving demand for that.
Very, very interesting. A controversial question for me personally.
I love it.
Since we're talking about it, maybe you've heard of the saying, all fiat goes to zero. What do you think? What do you think? Are we eventually going to see, a collapse of state-backed currencies, and are we going to eventually back everything by Bitcoin or Ethereum or something like that?
I mean, I don't like to deal in absolutes, so I don't know right now, but it is a very interesting notion to consider, seeing as with the pandemic, right? All these stimulus coins here in Canada, CERB and the extended EI, we're printing money like we've never printed it before. And, for example, I was just in Lebanon, and there's a run on cash. You can't take out more than, I think, $100 a week. And their bank accounts have been frozen. The banks are holding the cash that was in the account, so people can't leave the country. The currency is actively being devalued, right? There is actually a black market to buy cash. So when you go to a bank, you get it at a rate of 1,500 it's like 1,500 Lebanese lira per dollar. When you go to the black market, you get it for 8,000 Lebanese lira per dollar. And so this is what happens when you have devaluing of currency, when you're printing currency, in a completely unsustainable and almost unregulated way. So I think, there is the opportunity for cryptocurrency to come in and solve a lot of those issues, because we haven't really seen the effect of the pandemic on the economy. We really haven't seen the effect of the economic depression and the inflation that's going to occur as a result of all these measures that we're just putting in place to keep people afloat. So when we really start to see the effects of that, I think there's going to be a really strong look into cryptocurrency, because you can't print it, you can't mint Bitcoin.
Yeah. So, I mean, who knows? We don't know what the future holds. We can only make our best gets, our best bets, our best guesses. My bet is in cryptocurrency. I think it's I believe in a great degree of what was proposed by Code is Law. At least I can vet it. At least I can read it and see what it's going to do. Who knows what our monetary policy will be tomorrow or anywhere in the future.
So would you be Ethereum Classic or regular Ethereum? How devoted to Code is Law are you?
Yeah. So, I mean, I don't think it's either. I don't think you necessarily have to pick one camp.
Hmm.
I think that Ethereum today is still code is law to a great degree.
Yeah.
I think we learned a big lesson in in what happened with the
Yeah.
DAO, and we continue to learn big lessons moving forward with all these different new DeFi plays and people
Hmm.
dumping in money and losing tons and
The
making
pump and
tons.
dump. Yeah. Mm.
Yeah, I mean, and it's even more than just like pump and dumps. It's like rug pulls
Yeah.
and like yeah, we're still very new in the space. But that being said, the contract does what the contract says it's gonna do,
Yeah.
and and that doesn't mean that there isn't loopholes in the contract. Much like there are contracts in the real world that we rely on, and people find loopholes in those contracts all the time. And then we have
Yeah.
arbitration in courts, which are based on a judge's subjective ruling.
Hmm.
The contract is the contract in computer code. There's no one to appeal to be
Yeah.
like this, that, or the next thing, or pass a judgment.
Yeah. Which
So
is
I
good
like,
and bad, you know.
yeah,
There's
yeah,
no human interference, but there's also no human interference. So,
yeah, yeah. So we need to be sure. We need to vet things more. We need to maybe have groups that do audits, which we do, and they're
yeah.
getting better and bigger. And I think we're gonna find our way through it.
Yeah, regulation and regulation's a very scary word for a lot of people and it's a very polarizing word. But
Hmm. Hmm.
and again, regulation doesn't mean completely regulate everything to the point where it's exactly like the industries that we're used to now. It's just kind of a guiding principle to move forward with, I think.
Yeah.
Um, yeah.
Yeah. Amazing, amazing. I loved our chat. We got a little controversial. We got deep
Yeah.
into it, but hopefully the folks enjoyed learning today, and I certainly loved your presentation. It was super beneficial. So I thank you, Kate, for tuning in today, for giving us that great talk, and I hope to see you again in the future. I know Ben is been a partner with us and been working with us to put on BlockHack, and so I hope we can continue putting on great hackathons and putting out some great educational material in the future.
Yeah, this has been great. Thank you for having me and letting me give my presentation on behalf of Blockchain Education Network. Check us out, blockchaineducationnetwork.org. We have a
Yeah,
really cool wiki of free resources, tech, like tech, non-tech, everything. And yeah, really, really glad to be here and to be a part of this. And thanks for having me.
awesome. And yeah, on a quick note, if you came here and you haven't already signed up for BlockHack, make sure you go to www.blockhack.ca, sign up, and build a business in the blockchain space and get seed funded. All right.
Yeah.
And I will see you guys over in the Discord once you've signed up and we got your back. We will make sure that you get some mentorship and education, and we'll support you the entire way. So. On that note, I will bid you guys adieu, and I will see you later on in a few hours in the next workshop.
Yep.
Take care.
Bye, everyone. Thanks.
Bye.